Hello students, in the last class you have learned about the Bernoulli distribution, and in today's class we'll be learning about the binomial distribution. Yes, I think you have understood about the Bernoulli distribution as well as how to solve the problems or the questions related to the Bernoulli distribution, because I have helped you how to solve it, right? And today you will learn about binomial distribution. About the binomial distribution, you have learned it in connection with Bernoulli also, right? So let's try to understand the binomial distribution. Binomial distribution also discovered by James Bernoulli. Who is this person, James Bernoulli, that they gave that binomial distribution is also discovered by? Whether James Bernoulli found or discovered anything else? Yes. He told about the Bernoulli distribution also, or he discovered Bernoulli distribution also. Maybe he found some of the drawbacks that he discovered binomial distribution. Binomial distribution also discovered by James Bernoulli. This is a discrete probability distribution. This is the point you need to remember, that as we have learned earlier, the four distributions are the discrete probability distribution, right? This is also one of the discrete probability distribution. Now the next one is the important task to learn is the definition. Yes, I told you that if you learn Bernoulli distribution's definition, all other distributions definitions are interlinked so that you can easily learn it. Yes, the definition will be, as you know, the Bernoulli's definition, will write that first. If x is a discrete random variable, if x is a discrete random variable with the probability mass function p of x is equal to p to the power x q to the power n minus x, where x is equal to 0, 1 and p is equal to, p is from 0 to 1 I said, that is nothing but 0 less than p less than 1, and q is equal to 1 minus p, then x is a Bernoulli variate, whereas the distribution of x is called the Bernoulli distribution, right? Now let's connect this with the binomial distribution. If x is a discrete random variable with the probability mass function p of x is equal to ncx p to the power x q to the power n minus x. Hope you are understanding. P of x is equal to ncx p to the power x q to the power n minus x. And then we'll write about x, that is 0, 1, till n. Then p is from 0 to 1, q is equal to 1 minus p. Then x is called the binomial variate, whereas the distribution of x is called binomial distribution. Very easy to learn it, right? If x is a discrete random variable with the probability mass function p of x is equal to p to the power x q to the power n minus x, here it is 1 minus x, then x is equal to 0, 1, whereas it is from 0 to 1, that is p, probability is from 0 to 1, whereas q is equal to 1 minus p, then x is a Bernoulli variate, whereas the distribution of x is called the Bernoulli distribution. Whereas when you come here, it will be if x is a discrete random variable with the probability mass function p of x is equal to ncx p to the power x q to the power n minus x, where x is equal to 0 to n, p is from 0 to 1, that is 0 less than p less than 1, q is equal to 1 minus p, then x is the binomial variate, whereas the distribution of x is binomial distribution. So this is about the binomial distribution's definition. We'll see some more details about it. Binomial distribution has n independent Bernoulli trials. I told you that if x is a Bernoulli trial, then x1, if you are repeating that, x1, x2 or x3 till xn is nothing but binomial. It will be the binomial distribution, right? So they say binomial distribution has n independent Bernoulli trials. These are the Bernoulli trials. Here n is finite and fixed. Here n is finite, the definite number you are going to give, and it is fixed also. Each trial can result either in a success or failure. As we know, it will result in either in success or failure, as it was there in Bernoulli distribution. Either it it will result in the success or failure, presence or absence. They are mutually exclusive and exhaustive. You have learnt about this in the first year. They say that they are mutually exclusive. Mutually exclusive is a situation when you do A intersection B, you will get it as a null set. Means the occurrence of event A prevents the occurrence of B. If A is an event about occurrence of head, if head occurs in the toss of a coin, of course no tail. Hope you are understanding. It is resulting in no tail, right? The occurrence of one event prevents the occurrence of another one. Now, if B is an event of that is you are observing about a tail, then if when you are tossing a coin, if the tail occurs, it does mean that it is preventing the occurrence of head. So, in such a situation, A intersection B, when you do, if you are getting a null set, that event is called what? They are mutually exclusive. Whereas they say mutually exclusive and exhaustive. But when you do A union B, whatever the possible total number of possible outcomes, whatever is there, it will be there in that event. That is, A union B is equal to sample space. Sample space means what? In a toss of a coin, only the possibilities are head, tail. That's all, right? So sample space contains H and T. That's all. Whereas if it is about rolling a die, in dice you can see 1, 2, 3, 4, 5, 6. So when you do A union B or A union B union C, what is going to happen is you will get the sample space in total. So they say they are mutually exclusive and exhaustive. Hope you understood. And the probability of success be same for each trial. Probability of success remains the same for each trial. If it is about a coin, 1 by 2. Occurrence of head is, the chance is only 1 out of 2 outcomes. Whereas the occurrence of, while you are rolling a die, if the occurrence of 6 or 5 is noticed, only one number out of 6, right? 1 by 6 is the probability. So they say the probability of success, say P is same for each trial. Now the binomial distribution is written with the parameters. Binomial distribution with parameters n and p. Now you came to know that the parameters of binomial distribution are n and p, and you learnt one of the feature of binomial distribution, that it is n and p, and you have learned another feature that the p of x is equal to n cx p to the power x q to the power n minus x. Two features we have already learned. Now let's write the distribution of that is the binomial distribution so that we can understand it. Yes, we know that the distribution, probability distribution is written like this, x and p of x, right? The probability distribution, this is how it is written. So you will start from 0, 1, 2, 3, 4, how many times the trial is it is experimented. So based on that you are going to write the numbers. So it is till n. How you are going to do that? It is based on the probability mass function, n c x, right? So if n is equal to 4, then you will write 4c0 into p to the power x. Then for example, if it is 1 by 2, 1 by 2 to the power x, x is nothing but 0, and 1 by 2 to the power remaining, that is q, 4 minus 0. Hope you are understanding. So this you have to do, right? The next one will be 4c1, 1 by 2 to the power 4cx, right? P to the power x, right? X is nothing but 1. 1 by 2 to the power n minus x. N is 4. N is 4, the last number. N is 4. That is 4 minus 1. Hope you are understanding. This is how you can solve. They say that 4c0 is equal to 1, as you know. 4c1 is equal to 4, as you know. So this can be solved using the Pascal's triangle. They say, yes, you have learnt about the interpolation, extrapolation, and you know that how to write the Pascal's triangle, right? We start from 1, then we write 1, 1, and for n is equal to 2, you write 1, 2, 1, and then you write 1, 3, 3, 1, whereas next you write 1, 4, 6, 4, 1. So they say that using the Pascal triangle also we can do it. If n is equal to 4, you can write this numbers as directly 1, 4, 6, 4, 1. We'll get it so. even if you do 4C0, 4C1, 4C2 and all, you are going to get the same. Yes, so this is how you are going to write the binomial distribution. So, if n is equal to 4, then p is equal to 1 by 4 they are telling, then the binomial distribution is as follows. This is how it will be written, they are telling. Okay, 1 by 4 or 1 by 2, whatever it is, we'll be writing 4C2, 1 by 2 to the power 2, 1 by 2 to the power 4 minus 2. In the same way, you will be writing for all till 4 you will be writing. Then if n is equal to 5, how to write, that is also given in your book. So there are n plus 1 probability terms. Even if there are 4 times you are continuing, but you will be writing till 1, 2, 3, 4, 5 terms will be there of probability terms. Why is it so? Because for example, if the observation is about the head, there is a possibility of no head. There is a possibility of 1 head, 2 head, 3 head, 4 head. Hope you are understanding. As 4 coins are there, you may get 4. In the 4 tosses also, it may result in head. Or it may result in 3 heads and 1 tail. 2 heads and 2 tails. Or 1 head and 3 tails. Or 0 heads. Possibility is there. So it is about that. Not about the number of coins. If it is about the number of coins, you may write 1, 2, 3, 4, 5. It is about the observation. Based on what observation you are doing. That is about the number of heads if it is. Then even if 4 coins are there, you will be writing 0, 1, 2, 3, 4. Hope you understood. Even if it is about the dice which are rolled, if you are observing the number 6, there is a possibility that you may not get 6. While you are rolling the die for 4 times. Hope you are understanding. So it comes with no 6s, right? No 6, 1 6, 2 6, 3 6, 4 6, 5 6. Hope you are understanding. If you are doing it 5 times, then you may get 5 times also 6. There is a possibility. I am not telling that each and every time you will get so, but these are the possibilities you may get. So they are talking about that. So they are telling that there are n plus 1 probability terms. 1, 2, 3, 4, 5. N plus 1 probability terms in a binomial distribution. The successive probability terms are the successive terms in the binomial expansion q plus p to the power n, which is not important. Sum of all probabilities is equal to 1. Yes, this thing you need to notice that whenever you do p of x total, you will get it as 1. The total probability is always equal to 1. Okay, so they say that sum of all the probabilities is equal to 1 because binomial distribution is a probability distribution. In a binomial distribution, if you find the total, you will get it as 1 because it is a probability distribution. The probability distribution, you have learned about it in that I have told you that the probability total will be summation p of x will be equal to 1. In the chapter random variables, we have learnt about it, right? A binomial distribution with the parameters n and p is denoted by, how to denote it? B of n comma p. This is if you learn this, that is enough. B of n comma p. Now some of the examples given for the binomial variate. Number of heads obtained in a coin, of course, while you are tossing a coin. So, but how many times it is tossed? 4 tosses, right? Number of heads obtained. If it is about a coin, only 1 time you are doing it, it comes under Bernoulli. Whereas if you are repeating the trial several number of times, then it comes under binomial. The number of heads obtained in 4 tosses of a coin. Number of male children in a family of 2 children. In a family of 2 children. Number of bombs hitting a target among 3 bombs which are aimed at it. And the number of defective articles in a random sample of 6 articles. If it is about a 1 article, it is different. So 6 articles are there. You can see the n is definitely, it is given. It is fixed and it is given to you. 6 articles. Number of seeds germinating among 10 seeds. It is not about 1 seed, whether it will germinate or not. No, it is about the 10 seeds. What are the possibilities? So here each and every time you can observe that the n is given, or the trial, or it is trialed many number of times. So if it is done so, then it comes under binomial distribution. Now some of the features of binomial distributions, which are, we have already learned the two binomial distribution features. N and P are the parameters of the binomial distribution. N and P are the parameters. Then comes x is equal to 0 to n, right? X is equal to 0, 1, till n. Whereas the binomial distribution probability mass function is P of x is equal to NCx, P to the power x, Q to the power n minus x. X is equal to 0 to 1, P is from 0 to 1, and Q is equal to 1 minus P. So the three features we have already learned while learning the definition and other points, right? Okay, about the parameter, about the range, and about the probability mass function. In connection to that, we have learned about P and Q also, right? Okay, now for a binomial distribution, we know that in a Bernoulli distribution, mean is equal to P, right? Mean is equal to P, variance is equal to PQ, and standard deviation is equal to square root of PQ, right? In a binomial distribution, what is extra? In a binomial distribution, the parameter n is extra. So mean is equal to np, variance is equal to npq, and standard deviation is equal to square root of npq. Yes, the mean is equal to np, variance is equal to npq, and standard deviation is equal to square root of npq. And mean is greater than variance, as it was there in the Bernoulli distribution. Even if you do the calculation also, you will get it so. That is, mean is greater than the variance. We'll try about this one, that is about the coin. If it is tossed 5 times, 5 into 1 by 2 when you do, as well as 5 into 1 by 2, and Q is equal to 1 minus P, that is also 1 by 2. So do this and check whether mean is greater than variance. You will get it as mean is greater than variance. Check. Okay, so then comes the mean and the mode are equal if NP is an integer. So they say they are talking about the mode also. And they are telling that mode is equal to mean, it seems. Whatever the calculation what you do here, that is also equal to the mode when NP is an integer, right? When NP is an integer, we'll take this as 4 and we'll easily do it. Yes, here we get the answer as 2, right? Now 2 is a integer. 2 is a integer, right? If NP is an integer, what they say? Mean is equal to mode. If NP is an integer, then mean is equal to mode, they say. And this is an integer number. And if it is a real number, then 2.5 or something if you are getting, then it is, yes, when you do this, that is, if it is 5, what will happen? You will get the answer as 2.5, which is not an integer, right? Mean is equal to mode if NP is an integer. Mode of the binomial distribution is equal to the value of x, which has the largest probability. Yes, the mode of the binomial distribution is equal to the value of x, which has the largest probability, they are telling. For example, whatever the calculations you are doing, whatever answers you are getting it here, for example, if you are getting it as 0.1, 0.3, 0.2, 0.2, 0.3, for example, we'll take it as 0.4. Hope you are understanding. They say that one which has the highest probability, the corresponding value x is there, no? That is the mode, it seems. The mode of the binomial distribution is equal to the value of x, which has the largest probability. So if it is not an integer, no need to bother, it will be so. One which has the largest probability. Then comes about P is equal to Q, which is equal to 1 by 2. If P is equal to Q is equal to 1 by 2, if this is the case, then what it is? If P is equal to Q is equal to 1 by 2, then binomial distribution is symmetrical, equally distributed. Then it is symmetrical. You have learnt about this in the first year. That is symmetrical distribution, equally distributed. If P is equal to Q is equal to 1 by by 2. It is about a coin, right? If P is less than 1 by 2, if P is less than 1 by 2 or Q is greater than 1 by 2, it is the case, of course. P is less than 1 by 2 means you will get Q as greater than 1 by 2. That's why they have given OR. That is, P is less than 1 by 2 or Q is greater than 1 by 2. Then binomial distribution is positively skewed. Okay, let me show you the symmetrical distribution for this. Symmetrical distribution means you will get that it is equally distribution. This is the symmetrical distribution. Whereas if P is less than 1 by 2 and Q is equal to greater than 1 by 2, we will get it as, for example, for the positive side it will be more. Hope you are understanding. It will be so. Got it? And if it is a vice versa, what will happen? That is, for the negative side it will be more. Hope you understood? So this is how it will be. So they say if P is greater than 1 by 2 and Q is less than 1 by 2, then it will be negatively skewed distribution. The binomial distribution tends to Poisson. The next one we need to learn what is the connection in between binomial and Poisson they are telling. Binomial distribution tends to Poisson distribution when n tends to infinity. This is very important for 1 mark or 2 mark. Okay, binomial distribution tends to Poisson distribution, the next one, when n tends to infinity, when n is very large and p is very small. When p tends to 0 or p is very near to 0 and n is very large, it will tend to the Poisson distribution where np is equal to what? Lambda, which is a parameter of Poisson distribution. Okay, no need to bother about it now, but you keep that in mind that binomial distribution will go to all, it will tend to Poisson distribution if n is very large and p is very small. The binomial distribution tends to normal, another one they are talking about. Okay, it tends to normal distribution when n tends to infinity and p and q are almost equal. Those are almost equal, they are telling. Okay, so n tends to infinity and p and q are almost equal. Our binomial distribution tends to normal distribution. These are the very important features of binomial distribution. I hope you are clear with it. So the first 2, 3 you can the 4, 5 points which are very easy. 5 points if you know, that is more than enough. But for the information, of course you should know about the mode, right, and you should know about the one which tends to the Poisson or normal distribution. So the points which are very important, of course all the points are important, but I will pressurize or I will tell you to learn the first 5 points which can be easily written for as a features you can write, and mean and mode connection you should learn, 6th and the 7th point you should learn, and 11th and the 12th point are very important. It will be asked for 1 or 2 marks. So learn about the features of the binomial distribution. Yes, in the next class we'll be learning about how to solve the problems, how we can solve the exercises or the problems which are given in the exercise easily. We'll be learning it in connection with the examples which are given in the textbook. Thank you.